Practice test answer time. Hi. I said to do this kind of matching thing on the test. I'm going to do that on the real test. I like it because I can test a bunch of concepts all at the same time. So look at what it was. You had a graph, you had a factored form, you had a multiplied out form. Now there's clues you can use to save a lot of typing in. You do not have to type in each of those functions and see which one they are. Oh my God, that would take forever if you're going to do it. It would work. If you typed them all in, it would work. But there's a faster way by being clever, by knowing the course material. So for instance, for the first one, that one has, it's a graph with 2 bumps, which means it has 3 for the highest exponent. It's got x cubed in it, at least. So now look at the other clues. You got a graph with 2 bumps, that's x to the 3rd power is in it. And you look at the multiplied out ones, there's only one equation with an x to the 3rd in it. So it has to be the choice. And then there's only one equation with 3 factors, which would have an x times an x and an x in it. You know, x times x times x if you multiplied it all out. So 3 factors, x to the 3rd goes with the 2 bump thing. The other 3 are quadratics. The other 3 only have x squared in them. So then you look and you see, okay, letter B, the graph is pointing down, which means it has a negative on the x squared. If you've been following along, negative on the x squared, the graph is pointing down. So I need a multiplied out thing that has a negative on the x squared, and I need somebody like 7 minus x, something with a minus x on it, to get the minus x squared. So that's how you decide $sign and heart. And then you go over to letter C, and you look at the graph, and it looks like it goes right through x equals 1. So if the graph goes through x equals 1, then you have x minus 1 for a factor. That decides what's left. And then you're looking for, say, what are the factors like? Well, that's good. And if you multiplied it all out, what would you have? Well, you'd have something that ends in, 1 times another number, looking for the right kind of stuff, and it's got to be a positive on the x squared, which is like both. Anyway, you look at the clues, and you can get that other clue. And then the last one is symmetric. You're looking for, well, not perfectly symmetric, but you're looking for a negative y thing like a negative 15, about the right size. When you look at the picture and you see the multiplied out one, the picture for D looks like it has a y-intercept around negative 15, and you have a term like that. And now you're looking for factors that have a 5. Somebody has to have a 5. Well, it decides the factored form. Or just type everything in and graph everything and see when things match. Be my guest, But that's I'd rather see you use your detective work. Like, I got some clues here. Let me put it all together. Number 2, you're only going to put a star in those 2 because one of the big ideas is quadratic formula always works. But if there's no x-intercepts to find, quadratic formula will give you a complex number. It'll give you something with a negative inside of the square root because there is no x-intercept. So when you go to quadratic formula, you're looking for the x-intercepts. But a parabola can miss the x-axis. It can be above it or it can be below it pointing down. If the parabola misses the x-axis, then you don't have any x-intercepts, and the quadratic formula would give you complex numbers for the roots. So that's what's going on with that. So the question was, who's got complex numbers that aren't real? And that's these 2, U-shapes that miss the x-axis. This guy here, number 3, they wanted exact, so you can factor it. It actually factors. And you see x equals 4 and x equals negative 1/3. You could have done quadratic formula. You'd get the same numbers when you simplify. It's a lot of work, but you could do it. But if you just trace it on the, if you just trace this on the graph, it won't give you exactly negative 0.33333333. And that's a problem. And if you ask for calculate the intercept, it'll give you 0.33333. But 0.333, negative 0.33, is not the same as negative 1/3. Negative 1/3 is infinite 3's. So if you write negative 0.3 bar, these are okay. But this will be points off because it's not exact. Hope that makes sense. So I'm telling you, you're going to have to be smart. You can't just, I'm going to just do whatever the calculator says. No. When it says exact answer, it's got to be exactly right. Number 4 was also exact. And I can't factor it. I try to factor it, it fails. So I do quadratic formula for number 4. And I get 11 plus or minus the square root of 73 all over 6. And that's exactly right. Just leave it. Full credit. Can you believe it? Almost done. Problem 5. It said give the approximate answers. So quadratic formula works great here. If you plugged it into your, if you did the program on your calculator, you literally only have to enter 1 for A, -10 for B, and 4 for C, and it pumps out these two numbers, 9.583 and 0.417. Now there's more decimal places, but notice I'm not going to accept 9 or 9.6. Give me a few decimal places. It's an approximation. Give me an approximation. Now the next one, number 6, we gave the factored form. So it's like giving you the intercepts. There's an intercept at 1, at 2, and at -3. And the y-intercept is at 6. If you graph this on your calculator and have the x scale and the y scale in ones, you can read the intercepts right off of the screen. There's no excuse. You got to get this thing right. The calculator does it for you. Number 7, you have to graph this thing. Now notice I chose a big number, -100. If your y-min doesn't go all the way down to -100, you won't see the bottom of the parabola. But you know it's there. You know that it's got to be when x equals 0, y is -100. So you know where it's got to be. Anyway, that's a graph. That's a full credit graph. And then you say, but McDaniel, that's 100 and this is 10. And I say, yeah, you know what? This is 1 and that's 6. It's fine. It's labeled. I can understand it. Anybody can understand it. Number 8, they wanted 3 positive x-intercepts. So I need to see factors like this. If you just guess and try to come up with something, good luck. But you make it happen. The x-intercepts here are at 1, 2, and 3. I'm not going to graph it. I don't need to graph it. I know it's going to have 3 positive x-intercepts. Number 9, you want to have a graph go through the origin. Well, you got to have a factor of x, just plain x. And then this will be an intercept at x equals -3, but they just said, give this 2 intercepts, one of them has to be the origin. Well, you got free response. Millions of answers possible for all these things. Millions of answers, but you have to make them. Now we're looking for a number that is less than itself squared. So this works for a negative. There's a lot of numbers that work like this. -1 is less than 1. 2 is less than 4. Whatever 7.3 is squared is bigger than 7.3. A lot of numbers work. But you know what fails? 0, 1, a half. They would be bad answers for number 10. You can't get this wrong. You got to get it right. Find a number that works. So I'm telling you, okay? I'm telling you. When I go to write up that test for Thursday, I'm using this as the template. What am I going to do? There's going to be a problem like number 1 with the matching. There's going to be things where graph the factored form and graph the unfactored form. Factor something, give me exact answers. All these questions are going to be on there. Questions where you have to use quadratic formula, they're going to be on there. You should crush this. I'm telling you what's on it. You should be able to crush it. So for me and Cocoa Bananas, we will see you on Thursday.